The Oort cloud, also known as the Oort cloud, is a hypothesized collection of countless icy planetesimals encircling the Sun at distances spanning from 2,000 to 200,000 astronomical units. Initially suggested in 1950 by Jan Oort, a Dutch astronomer, the cloud serves to maintain a steady flow of long-period comets into the inner solar system, where they ultimately meet their demise as they approach the Sun. The Oort cloud is believed to consist of two main parts, an inner disk-shaped section, referred to as the Hills cloud, in alignment with the solar ecliptic, and an outer spherical region enveloping the entire solar system. Positioned well beyond the heliosphere, both areas reside within interstellar space. The innermost area of the Oort cloud lies over 1,000 times farther from the Sun compared to regions like the Kuiper belt, scattered disk, and detached objects, which are closer reservoirs of trans-Neptunian objects. This distant boundary of the Oort cloud signifies the cosmographic frontier of our solar system, marked by the Sun's Hill sphere, straddling the boundary between the gravitational realms of the solar and galactic systems. The outer section of the Oort cloud exists in a tenuous connection to the solar system, making its constituents susceptible to the gravitational influences of passing stars, the Milky Way galaxy itself, and the cloud's internal microgravity. These gravitational forces play a crucial role in tempering and smoothing out the highly eccentric orbits of material expelled from the inner solar system during its formative years. The circular paths followed by objects in the Oort disk are largely a result of this galactic gravitational nudging. Consequently, the interference of the galaxy in the movements of Oort cloud bodies occasionally dislodges comets from their orbits within the cloud, propelling them towards the inner solar system. Based on their trajectories, most short-period comets are believed to originate from the Oort disk, although some may trace back to the larger spherical cloud. Astronomers theorize that the material currently existing in the Oort cloud initially formed nearer to the Sun within the protoplanetary disk and was later scattered far into space due to the gravitational influence of the giant planets. Despite the impossibility of directly observing the Oort cloud with current imaging technology, it is considered the primary source replenishing long-period and Halley-type comets, which eventually vaporize upon nearing the Sun after entering the inner solar system. Additionally, the cloud is thought to play a similar role for numerous Centaurs and Jupiter family comets. Research points to the Oort cloud forming around 4.6 billion years ago, following the birth of planets from the primordial protoplanetary disk. Initially close to the Sun, objects in the Oort cloud underwent significant gravitational disturbances from young gas giants like Jupiter, leading to widely elliptical or parabolic orbits. Subsequent interactions with passing stars and massive molecular clouds further shaped these orbits into the detached, long-lasting paths seen today. Recent NASA studies suggest that material exchange between the Sun and neighboring stars during their formation contributed to a significant portion of Oort cloud objects, hinting that many of these objects did not originate near the Sun. Computer simulations depicting the Oort cloud's evolution since the early days of the solar system indicate a peak mass approximately 800 million years post-formation. As the rate of accretion slowed and depletion took over, the cloud's mass began to decline. Julio Angel Fernandez's models proposed that the scattered disk, a key source of periodic comets, could also be a primary contributor to Oort cloud objects. Approximately 1/3 of the scattered disk's population is projected to end up in the Oort cloud within 2.5 billion years. These models underscore the substantial role that collisions of cometary debris played during the solar system's inception, with a more significant impact than previously understood, resulting in a lower total mass for the Oort cloud than previously estimated. Conversely, the Hills cloud, more strongly bound to the Sun, has not adopted a spherical form. Recent findings also link the formation of the Oort cloud to the early solar system existing in a cluster of 200 to 400 stars, where close stellar encounters were more frequent, potentially impacting the cloud's development significantly. Moreover, studies suggest that the solar system captured comets from its birth cluster, potentially exceeding 90% of Oort cloud comets originating from other stars' protoplanetary disks. This influx from the Sun's birth cluster could provide insights into the observed ratio of outer Oort cloud to scattered disk objects and increase the likelihood of capturing a Planet 9. Within the Oort cloud, cometary remnants from the solar system's formation, stored in both the Kuiper belt and the Oort cloud, exhibit distinct characteristics based on their origins and orbits. Short-period comets typically arise from the Kuiper belt or the scattered disk, while long-period comets, such as those from the outer Oort cloud, boast orbits lasting millions of years. The Kuiper belt's stable orbits make it less likely to be a significant source of comets, with the scattered disk showcasing more dynamism and acting as a primary comet originator. As comets journey from the scattered disk toward the outer planets, a transformation occurs, turning them into centaurs before further evolution into short-period comets,